Hello guys, today I'll be going over the 2001 IMO shortlist, the first geometry problem with G1. So let A1 be the center of the square inscribed in an acute triangle ABC with two vertices of the square on side BC. Thus, one of the two remaining vertices of the square is on side AB and others on AC. Points B1 and C1 are defined a similar way for inscribed squares with two vertices on sides AC and AB respectively. Prove that lines A, A1, B, B1, and C, C1 concur. So this is what the diagram sort of looks like right now. And well, this is nice and all, but these points are terrible because soon they'll be very cluttered and it's just very hard to prove. But there is one way we can fix this, and it's called homothety. So we know that this triangle is similar to this big triangle, so we can perform a homothety centered at point A, but dilates it down here. So now this is the new A prime. Let's just call it A1. And so we can do similar things with the rest of these. C1. Okay, so now let's connect these lines, right? So we know that A1 has to lie on line A prime. So if A prime and if A prime are collinear, then so is A. Also, let's call it A2, I guess, because we already have A1. But yeah, so if they are collinear, then these are also collinear because B2 lies on line B1, and A2 lies on line A1, and so does C. So this graph is a little bit inaccurate, but you get the point. Okay, so now we want to use Chavis theorem. So first of all, let's try to get a grip on what we're asked for. So we have A2. Let's do law of sines on ABC. And also what we want to use is we want to use the trigonometric Chavis theorem, which states sine B A2 over sine A2 AC times sine CBB2 over sine B2 BA times, let's just connect this for simplicity, times sine A C2 over sine C2 CB. So you want to prove this is equals 1, right? So let's first take a look at this. So by law of sines on triangle ABA2, we get AA2 over sine ABA2 is equal to BA1 over sine BAA2. Sorry, I meant A2. So let me just move it down here. So we have this, right? What is sine ABA2? Since this is a square, we know this angle is 45 degrees. So we know that ABA2 is just B plus 45. And BA2, since A2 is the center, is equal to CA2. Now, similarly, let's do law of sines on triangle ACA2. So we get AA2 over sine C plus 45 is equal to CA2 over sine CAA2. So we get that sine BAA2 over sine A2AC, this is just equal to sine B plus 45 over sine C plus 45. So now I'm just gonna spare you guys the calculations, but we can do similar calculations on the other two on the other two squares, and from this we get sine b plus 45 times sine c plus 45 plus sine a plus 45 by symmetry, and this is all over sine c plus 45 sine a plus 45 times sine b plus 45. And like I said, these all cancel out. So this is equal to 1, which means that they concur. Thank you guys for watching. If you enjoyed this video, make sure to like and subscribe. And if you like this video, make sure to check out our other IMO videos that I have recorded. Peace.